Hi developers, I'm Hosam Delai, Microsoft MVP. In this Lightboard session, I'll give you an overview about the API gateway. So we'll see what is an API gateway, how we can use it in the context of microservices architecture, and what are the benefits and the drawbacks of such an approach in terms of security and latency for our application. So let's get started. When we are developing software application using microservices, we might have actually different microservices. So we might have microservice number one, responsible for the catalog services, for example. So let's draw this one right here. So this is my microservice number one. I might have another microservice responsible for the product's pricing, for example. So this is going to be my microservice number two. And I might have many microservices, hundreds or dozens of microservices. So let's say this one is my microservice number n. And from our application, when we want to connect to those microservices, we might have different types of applications, what we call front ends. So we might have web application, like a SPA application based on React or Vue.js or Angular, or we might have also mobile applications. So anything that could be a front-end application. Here, let's take the example of having a web app. So let's draw that here. And this tier, I'll have my web app represented as this is the front end for my application. And those are my microservices, or my backend actually. From the front-end application, if I want to connect to those different microservices, then here I can use direct connection from the web app to the microservice. So if the web app wants to get the list of the products from microservice number one, it will connect directly to that microservice and get the response back to web app. But if in addition to that information, it wants to get the pricing for each product, then it needs to create another connection for microservice number two and get the response back. This means that those microservices should be exposed publicly to my front end, which also means that here I need to have public IP for each microservice. So for my microservice number one, I have public IP, and also each one of my microservices should have a public IP with the port number. This means that those microservices will be exposed publicly through the internet. They will be exposed to the hackers. So this is a security issue. Let's mention that here. In addition to this security issue, because of exposing those public IP addresses to the internet, we'll have another problem actually. We said if web app needs to get information from 2, 3, or 5 different microservices, then it needs to create a first connection to the microservice number one, get the response back, then create a second connection to microservice number two, get the response back, and the same for my 5 microservices. Then at the level of the web app, at the end of those 5 microservices calls, it will aggregate the data inside the web app. So this is lots of connections between the web app to the microservices, and we want to reduce this number of connections in order to have less latency inside our application. So that's the second point that we want to address with the API gateway. It's the latency of the requests. So as we said here, the solution would be simply using the API gateway. So what is an API gateway? So as we said here, for the web app to connect to those different microservices, it needs to know their IP addresses. So it's coupled to those microservices with their IP address. So instead of having the direct connection between the web app and the microservice, what we'll do here is that we'll introduce a middle, in the middle here, which will be the API gateway. So here we'll introduce something, let's say it could be another microservice at the middle right here. So we'll add another component. And this one is the API gateway. It's basically another microservice that the app should go through it in order to call those different microservices. So if here I have a request from my web app to get information from those microservices, I don't want to go directly to the microservice, but needs to pass through the API gateway. So basically an API gateway is like a reverse proxy that will get the client request and redirect it to the microservice that the web app wants to connect to. So it will just get that request, then redirect it to the following microservice. If it gets the response back from that microservice, the response back will get back to the API gateway. Then the API gateway will return that response to the web app. So here we'll have a response. This is the basic functionality of an API gateway. It gets the requests from the web app, redirect them to the microservice, then get back the response to the web app. This basic feature, the reverse proxy, solves the problem of security. How? Because here we don't need to have those IPs as exposed as public IPs over the internet, but because the API gateway and those microservices could live inside one network, and that network could be secured. So all of those, as part of my backend, could live inside one network. So let's draw that here. So let's say this part could live inside a secured network, which means that those IP addresses will be private IP addresses. And the only IP address that we'll expose here is the one for the API gateway. So here, this will be a public IP address so that the web app could retrieve the API gateway through its IP address. And now the API gateway and those microservices could live inside the same platform, or they could use a shared network infrastructure in order to communicate together in a private network. So those IP addresses will be private, and then they are not accessible to the public internet. So this solves the problem of security for the microservices. So we'll have less surface for attackers in order to attack our microservices. If they want to access my system, then they need to go through the API gateway. I only have one publicly exposed IP address instead of all the IP addresses for my microservice. So that enhances security for my app. So here, the security will be solved by using the private IP. Now for the second problem, for the latency of those requests coming from the web app to the different microservices, if we don't have API gateway. Now, actually with the API gateway, the client or the front end needs only to send one request to the API gateway, and it's up to the API gateway to know from where to get the data from those different microservices. So here, for the sample of getting the products details with their prices, a first request could go to the microservice number 1. We get back the part of the data right here, the details for the product. Then a second request could be issued by the API gateway to the microservice number 2 in order to get the pricing for the products. And we can have as many requests as we want here, and the data will be aggregated at this level, at the level of the API gateway. So here we create the view model that contains not only the product details, but contains also the pricing for the products. And here the response will get back to the web API. So what have changed here is that instead of the web app sending multiple requests to the different microservices, then aggregating the data at the web app level, now the data or the requests will be sent through the API gateway. So here we'll have less latency than previously with the web app sending the requests directly to the microservice, because as we said, this could live inside the same network, and this is a server component. So here we have good internet connection. So the API gateway could aggregate data at this level. So that's why here, instead of having the latency between the front and the backend, here we can use the aggregate pattern in order to reduce the latency of the requests. So with an API gateway, we'll have those two main benefits: enhanced security and latency for our microservices. But when we implemented API gateway, we saw that actually we can get benefits of some other cool features that could be implemented at the API gateway level. Those could be the cross-cutting concerns. First of all, we have the authentication and authorization. Before having the API gateway, the web app, if it wants to connect to any of those microservices, the microservice should implement the authentication and authorization in each one of those microservices. This means we'll have lots of duplicated code, and if you want to update the authentication or the authorization code, then we need to update it in all the microservices, and that's lots of pain, and that's not good in the point of view of good practices when writing the code for my app. So that's one added benefit. Actually, those are benefits of the using API gateway, and to this list I'll add here authentication and authorization. A second advantage is the service discovery, because here the API gateway could know the different microservices that have it here, because each new microservice will expose its own Swagger API definition to the API gateway, so that the API gateway could know those different microservices. So I don't have to update the web app. Thus, I'll have less coupling between the web app and the different microservices. The only coupling I have it here is between the web app and only one API gateway, instead of coupling it with multiple microservices. So this enhances service discovery integration. Another advantage is the response caching. So instead of implementing this in all my microservices, I can implement response caching only on the API gateway. So again, I'll have less code for my microservice. I'm actually putting only the main business logic code inside my microservice, and I'm extracting all the cross-cutting concerns from my microservices and adding them to the API gateway. So I'll have lighter microservices with cleaner code and code responsible only for my business application logic code. So this enhances the response caching. When we use microservice, we want our application to be highly available. For that, we tend to implement the patterns for retry policies and circuit breaker. If the first request fails to my microservice, then I might retry after 2 seconds, after 4 seconds, and retry again after 8 seconds, and so on. until I have reached like retries during for 4 minutes, for example. Then if for some reason we might think that the microservice one would be saturated, then we should stop sending it requests through using the circuit breaker pattern. Those different patterns will be translated into code and added to my microservices, to each one of the microservices. With using API Gateway, we can extract that code from the microservice to go to live inside the application or the API Gateway. Again, we'll have lighter microservices. So let's add that here as an advantage. And here we'll say the retry policies and the circuit breaker. Another advantage is coming when we want actually to apply a limit for the number of requests to each microservice. We say, for example, I cannot call microservice number 1 more than 100 times in 1 second, for example. We can apply that if we have external access to our microservices. Applications like third-party applications that wants to access my microservices. So I want to limit their access to my backend. We can implement that in all my microservices, but using API Gateway, we can apply those limits to or inside the API Gateway, because at the end it gets all the requests. So it can know who is the issuer of that request, and it can monitor and see how many times it did connect in a second or in a minute. So let's add that here as rate limiting. Another responsibility that could be extracted from the microservice to go to the API Gateway is the load balancing. So if I have multiple instances of microservice number 1 and I want to load balance the requests between those different instances, then instead of implementing or adding some code or some API right here before the microservice number 1, I can implement that inside the API Gateway, and they can define multiple policies for distributing the charge or the requests on top of the different instances of my microservice. So again, that's the load balancing. Another cool feature is to extract the logging, tracing, and correlation from the microservice to the API Gateway. At this level, we can trace or we can log all the requests coming from the web app. And at this level, we can see to which microservice those requests will go, and we can create some logging data at this level to track each request and each response to my web app. Now, because we get this request from the web app, at this level, we can apply transformation for this request. We can add headers for authentication, for example, or for authorization, and we can apply any kind of transformation to the request or also to the response coming to the web app, like adding some new attributes into the model that will get back to the web app, or removing data, especially here for aggregating that data coming from the microservices. So here we'll not query transformation. The API Gateway will get all the requests coming from the web app, so it can track and monitor each web app or each third-party application that wants to connect to my microservices. Thus, it can stop those connections to my microservice, because it have the feature that can whitelist the API or the IP addresses coming from the different client applications. That's useful to stop attackers from using things like DOS attack to my microservice. So this is the IP whitelisting. So here we mentioned the different advantages of using API gateway, but at the end it have also some drawbacks, some actually serious drawbacks. One of them is because the API gateway is the only or it's getting all the requests from the web app. Here we are creating a single point of failure for our entire application, because if the API gateway will get down, or if it crashes or doesn't work for any reason, then my entire application won't work. So that's an issue to be addressed through scaling the API gateway. So we might have, for example, multiple instances of the API gateway. If one instance gets down, then the second and third instances will get the load instead of the first one. So this is worth mentioning, single point of failure for this API gateway. The API gateway is the concept. In terms of implementation, or in terms of tools, we have multiple API or multiple tools that uses the API gateway. One of the most known tools is Kong, which is an open source project available on GitHub. They have an enterprise offering also. Another API gateway that is really known at the open source community is Ambassador. We have also Oslet, which is a .NET Core API gateway. So it's implemented using C#, and we can change even the source code of this API gateway. We have also other offering from Azure, for example. Azure have this thing called Azure API Management. And the other cloud vendors like Amazon Web Services and Google, they also have their own offering for API gateway. I hope you liked this video, and thank you.